So listen, I didn't like how she did 1.3 day 2. So we did 1.3 day 1 yesterday, and then we did the practice set 1, the first set of homework. We're not going to be using her day 2 stuff. So if you can safely get rid of it, and when I say safely, I mean make sure like the next section doesn't start on the back of one of the pages or whatever. I'm fine with throwing it away, but not right this second. So let's get through the notes and if you want to do it. Because there's also something else I'm giving you today, which is the rest of Unit 1. So you're getting down to the wire with your paper in there because I think it stopped somewhere in 1.4 in the packet I gave you. I'm going to give you the rest of the unit when you guys are working on the homework, okay? Just a couple reminders. The Algebra 2 retake is Monday at the end of class. So when you come to class on Monday, we're going to do a quiz review worksheet. No new notes, just working on practicing for the quiz with my help. And then the last 10-15 minutes of class is a 6-question quiz for any of you that have your quiz corrections with you. If you don't have your quiz correction, you're not going to be able to make up or retake the quiz. It's a one-time deal, so be prepared. Okay, I went on the conference to look for you in case they were giving you a hard time. Okay, good. So guys, just understand, if you forget the corrections tomorrow, or you don't do the corrections, you just hand me the quiz like I gave it to you, you're not going to be able to take the quiz. So be responsible. Put it in your phone. I need to bring my corrections. Put it in your notebook so you have it already done. Whatever. Okay. Then we'll do the quiz review Monday, and then the quiz on Tuesday. So there's no new material Monday or Tuesday. Then on Wednesday next week we jump into 1.4. Okay. All right. So I think you guys are going to find this to be pretty easy because we've been doing it for 3 days. So we've been doing average rate of change, AROC, sometimes called rate of change, sometimes called change in Y over change of X, sometimes called slope, sometimes called slope of a secant line. So all these different terms mean the same thing. Back to, remember I said I do this sometimes, back to Algebra 1 when you had to look at a table of values and find the first and second differences and evaluate that information. That's what we're doing, okay? But at its heart, the 2 types of problems that we're doing are just slope formulas, okay? So just as a reminder, with a line, we know the slope has a constant AROC, right? No matter what 2 points you pick, the slope will always be the same. So that's what this first example is talking about. The table gives some selected values of f of x. We're going to explain why this is not a linear function, okay? So what we know about linear functions is the slopes are all the same. So I can kind of predict here that when I do the slope formula with these points, I'm going to get different slopes, which is what's going to happen. So understand, this is a point, 1, 4, and this is another point, 2, 7, right? Those are just 2 points. I'm going to find the slope between them. And I'm going to do it right here, just nice and quick and not too fussy, but I'll show you if it confuses you seeing it in this chart. You can go off to the side and do it, of course. But I'm just doing second y minus the first y over second x minus the first x. And then simplify it. That's 3 over 1, which is 3. If you don't like working in the table, of course, go do the traditional side-by-side ordered pair, do 7 minus 4 over 2 minus 4, whatever makes you happy, okay? But this is how you're going to see the key, and this is how I do it, so you might want to just get used to reading the key like this, okay? Same thing, 10 minus 7 over 4 minus 2. Now the minute I get 3 halves, I know this isn't linear. Already I have 2 different slopes. I'm going to just finish it. 13 minus 10 over 8 minus 4, and we get 3/4. Okay, so why is this not a linear function? Slopes are different. What if 2 of them were the same and 1 was different? Would that be a line? Nope. All the slopes have to be the same. What if some are positive and some are negative but of the same number? Nope, that's not the same, okay? All right, so let's talk about what happens with a quadratic. Example 2, with me. consider the quadratic function. They're telling us it's a quadratic, okay? We're going to complete this table of values, and then we'll talk about the rest. So they didn't give us the y values. So we're just plugging and chugging through this x, y chart, table of values, into the given function. So negative 3 squared is 9, negative 1 squared is 1, and so on. And if you were going to put these in your calculator, I just want to show you something. I see students make mistakes all the time with this. They might type in negative 3 to the second power, and they'll say, and I'll mark it wrong or tell them it's wrong, and they'll go grab their calculator, and they'll be like, nope, see, told you, calculator's wrong. Calculator told me negative 9. But what's wrong with this problem, the way I put it in? The parentheses. Your calculator is really smart and intuitive. It's doing what you told it to do. It's following your rules because it's doing order of operations. It's doing exponent first, 3 squared. That's not a negative 3 the way it's written. That's a negative 1 times 3 squared. So that's 3 squared is 9 times a negative 1 is negative 9. So if you're going to put negatives in the calculator and do powers to them, you either just know the rules, even numbers are positive, or negative times a negative is positive, however you want to do it, but just if you're going to use your calculator, make sure you put it in correctly. Okay, so we complete our table values. So what they're asking in this little chart is what's the slope between these intervals, which is exactly what's here, from negative 3 to negative 1. So we're going to find the slope there and put it there, from negative 1 to 1 and so on. So again, with that slope formula, so I'm going to do 1 minus 9 over negative 1 minus negative 3, which is plus 3. And I get negative 4. Let's put that over here. From negative 3 to negative 1, remember our interval notation, x values. Okay, and let's just keep going. The minute I know I have a 0 in my numerator, it doesn't matter what you put in the denominator. You can skip that. 1 minus 1 is 0 over anything. Who cares? Will be 0. Nine minus 1 over 3 minus 1, we get 8 halves or 4. And 25 minus 9 over 5 minus 3 is 16 halves or 8. Okay. Now we already know it's not linear because they gave us the function and the math supports that, right? We don't have the same slope. These are called your first differences, okay? What we just did, and let me go back and say it, another way of finding, doing slope is calling those first differences, okay? So these were our, and you don't have to label this going forward, I just want you guys to know what you just did. So we just added another term for slope, right? Average rate of change, all those ones we just talked about. Now first differences. This is what they called it in Algebra 1, I'm sure, if you remember. And since this, so typically, well, we'll get to that. Yeah. So what we're going to do now, though, is find the second differences. So when you do the slopes, first differences, now we do the second differences, which is easier because there's no denominator. You're just doing the same thing you did over here, but just with a numerator. So it's 0 minus negative 4 would be plus 4. And when we have a quadratic, our second differences should all be constant, if we did it right. And we did. So between 0 and 4, that's 4 minus 0, we get 4. And 8 minus 4 is 4. Okay? So with a quadratic, the second differences are the same. Okay? Don't worry about that bottom question. So how are you going to be asked a question? I'm going to show you on the next page. If you're given a table of values, you're going to say, is it linear? Is it quadratic? Or neither? Okay? So if you do the first differences and they're the same, that's linear. If you do the first differences and they're different, then you have to do the second differences. Then it's going to either be quadratic or neither. Okay, so let's see what that looks like. So we don't need to do all of these. Let's do, I'm going to do B and C, okay? So real quick, let's try and make this quick. I'm just going to do my slopes. Is everybody understanding what I'm doing? Please ask if I'm losing you. So this is linear. Our first differences are constant. If they weren't, we'd keep going. Okay. Now I want to show you a shortcut. Some people hate shortcuts. Some of my students over the years are like, I don't want to know the shortcut. I'm fine with the way I've been doing it. Don't try and teach me anything else. But I like to share them with you just in case. You want it. It is kind of nice. If you look at your x's and they're all, they're spread out over an even interval. See how we're adding 2 each time? They're exactly equidistant from each other. We didn't see that here. Look, +1, +3, +5. We didn't see it on the other page, I don't think. When that happens, you don't have to do the denominator of your slope. You can just do the change in y part because it's going to divide each of those by whatever you get here, which will be the same the whole way down. So even though your numbers, and let me explain it better after I do it, okay? Because I can put them side by side. I have the shortcut way and the long way. So let's do the shortcut way real quick. So I notice, oh, all my x's are equidistant from each other. So I can just do the numerator part of my slope formula. Now, let me just show you. I did this problem was done in the key using the denominator part. See, we got 1. Oh, the keys are different. Sorry, it's got a 0 there, and I have a. Why does that keep happening? Just trust me for a second. All right, we know it's not linear, so we're going to go to the next differences, and we get 1 minus 2 is -1, and 0 minus 1 is -1, so we know it's quadratic. Now, if I had used the whole formula, okay, so I'm going to mess this up a little bit right here. If I had used the whole formula, I would have had 3 minus 1 in the denominator. 3 minus 1 is 2, and I would have had 1 as my first difference there. And I would have divided this by 2. I would have had 1. I then would have had 1/2 there. And then, again, dividing by 2, I would have had 0. But when I do my second differences, it would have been 1/2 minus 1, which is -1/2. 0 minus 1/2, -1/2. Even though the numbers in here would be different if I used the entire slope formula, the same outcome would occur. I would get different first differences and same second differences, which would lead me to a quadratic answer either way. Did I just completely confuse you guys? You understood that? Okay. If you didn't understand what I just said, just keep doing it this way, and that's fine. But my key does it this way on some of them, so I'll talk about that again in a second when we get to it. Okay? All right, so we just learned that with a table of values, we can easily tell if it's linear or quadratic without graphing, having an equation, or anything. Okay? Let's talk about concavity. This is the same idea, but easier, actually. So we've already learned this little box here. When you have a concave up graph or portion of a graph, the AROC or slope or whatever is increasing. And I'm going to show you this in a second. Concave down, looking like that, we are, oh, I have to fill in the word. I was looking for the word decreasing. I have to write it. Decreasing. And I have a hard time memorizing things, so I always need little tricks. So down, concave down, when it's opening down, is decreasing. So they have the same letter. And then increasing is the other one. Okay? So what are we talking about here? So it said the rate of change. So we still need the rate of change, but we're not looking at what, if they're the same or different, all that stuff. We're just looking at if are they increasing. Okay? So since we know, well, I'll just do it one more time. So 1 minus 4, just trust me, I'm going to do some of the math here in my calculator for you. You're going to get -30. Okay? Just trust me. I know you guys know how to do slope formula. -1 minus 1. My paper's bleeding through, sorry. 1.2 minus 1.1. Trust me, do your slope formula the same way we did on all the others. You get -20. And then when you do this one, you're going to get -10. So we go from -30 to -10. What do we know about those? Are they increasing or decreasing? Increasing. Be careful because, remember, negatives can be tricky. If you think of the number line, They're actually getting bigger as we go left to right. So these are increasing, which means our graph is concave up. Increasing, concave up. When I do these slopes, I'm telling you the work, I did the work for you. You get 30 every single time. This is a neither. It's not increasing or decreasing. The slopes are all the same. We know that's a line. Yeah. Right here. 4 minus 1 is 3, right? 4 minus 1 is 3. That's my numerator. And I'm going to divide it by 1.1 minus 1. Are you seeing that that's a decimal? Yeah, it moves a decimal point over. Okay. That's what we just let our calculators do that stuff for us. But you do get 30 the whole way down. And so this is neither. It's a line. Lines don't have concavity, right? They don't open up or down. They slant left or right, but no concavity. That's a line. And then the last one, you can trust me, you get 60, you get 40, you get 20. You would do this work on a test, a quiz, homework, whatever, but I'm just trying to save time. Obviously, these are decreasing, right? 60, 40, 20. Actual values are going down. That means we are concave down. Okay? So two types of problems. Linear, quadratic, or neither, using first and second differences. Concave up, concave down, or neither, looking at are we going up, down, or not. Neither of those. Okay? Yeah, scratching. Any questions before I give you what's exactly what to do on that homework page? It's the third page I gave you. Lots of paper in this class. I know. So there is a typo on that. Number 2, the first unit from number 2 So I'm going to just do number 1 with you. I'm going to do it the long way here, and then I'll show you the shortcut way. Because what I want you to see is that these are growing by 2. This is plus 2, plus 2, plus 2 the whole way through. Okay, so if we just do it the way I showed you, it'd be negative 5 minus negative 2, so plus 2, over 3 minus 1 is 2. And I'm just going to go ahead and do, let me finish the problem. That would be negative 3 halves. Okay, keep going. Negative 4 plus 5 over 5 minus 3, which is 2. I get 1/2. So I know it's not linear already, but I do know I'm going to have to check with second differences to see if it's quadratic. And it actually is quadratic. Okay, so I know it's not linear, but now I have to deal with fractions and doing second differences. So I'm going to do 1/2 minus negative 3 halves, and then this, and then this, and I'm going to get a second difference here. So I'll put 1 in the calculator, then I'll give you the answer. So the way, if you're going to type it in your calculator, just be careful with fractions. When you're adding and subtracting fractions, you really should use parentheses, okay? So I'm just going to go right into putting my, when in doubt, guys, if you're worried about a fraction and putting it in as division, which you have to on here, when in doubt, put it in parentheses. There are certain times, like with multiplication, it doesn't matter. But if you forget, like, do I have to or not? Just put parentheses. It's not going to hurt. Okay, so minus a negative, so that's plus, and I'm going to put in parentheses 3 halves. And like I told you before, you can close the parentheses, but if you're going to hit enter, you don't have to type that, okay? And you get 2. Now, let me just tell you to save time, you get 2 the whole way down, which makes it quadratic, okay? How could you have made that problem easier, hence no fraction? Here, because I noticed they were all growing by 2, I was able to just do -5 minus -2. I got -3. Where we had -3 halves here. I got 1 here, we got 1 half. I got 5 here, we got 5 halves. I got 9 here, we got 9 halves. So they're different numbers, means they're not linear, but when I did my second differences, I got 2's here, I got 4's here. Think about why. 4 divided by 2 is 2. It doesn't matter what these numbers are, okay? So that's why either one of these can be done. Simply, are the first differences the same? No, then it's not linear. Second differences, are they the same? Even though in this math they were 2 and in this math they were 4, they're all the same. So that made it quadratic. So it's just a nice little shortcut if you pick up on it, but like I showed you, it works if you do the denominator as well, okay? So here's the first 6. You can see I showed some of the work there, and I'm going to give you the rest of your packet. Did I say I was going to do that? I did. So I do this all the time. I can't remember what I say. So I'm going to give you the rest of your packet. When I give it to you, it's not too bad. Just put it at the back of all your white paper that you already have. And this will be a third of the year. A third of the entire year. Now it's just right away. Yeah, so wait. Before you guys do anything crazy, okay, remember at the beginning of the year, 2 weeks ago, and I said, Mr. Coach P didn't get all my copies done, but he gave me the first so many pages. I gave you those, and he said there's more coming. That's this. Okay, this is, you have like up to 4B right now in your binder. This is what it should be like. More, look at the bottom number. It should go right after 40, I think, is your last page. And I just gave you 41. I haven't given that. So don't throw anything away. Let's see what's in the back. It's just the rest of Unit 1. This gets us to like past Halloween. Yeah. It's only 3 units. You now have all 1. Explain it to everybody individually and mess it up. And you can write it out to me. Thank you, Steve. For years, I had students complaining about how thick the pre-calc was. Now we start complaining about how it's
I was excited. I was
excited. And then you'll see I got all different numbers all separate. And then you're going to get 1/4. Are those numbers? No. So this is I got it. Thank you. Hey. Hi. Where are you? Are you having a video tonight? Because you're applying? I'm sure. AP was top. AP. Yeah. The first difference? Yes. Which is nice when you're done with that problem. You get to move on.
hopefully.